So today we're going to finish up section 7.3. We're looking at log functions as inverses again, but today our focus will be on graphing them. So logarithmic function is the inverse of an exponential function. The graph here shows y equals 10 to the x, that's the one in red, and its inverse y equals log base 10 of x, and that one's in blue. Note that the points 0, 1, and 110 are on the original exponential function, and then their inverse is on the log function. So instead of 0, 1, we have the point 1, 0. Instead of 110, we have the point 10, 1. Recall that the graphs of inverse functions are just reflections of each other over the line y equals x. So we can graph y equals log base b of x as the inverse of y equals b to the x. Note that horizontal asymptote of the exponential function also flips to become a vertical asymptote for the log function. So with our exponential graphs, we had them leveling off right over here. With our log graphs, we're going to have them coming up along our vertical asymptote and leveling off there. All right, so the process for graphing them. It's going to start out as a log equation. Your first step would be to convert it back into its exponential form. So do your little loop. You start with your base to your power, which is the answer to a log, and it gets you back to that main number. So 3 to the y equals x. Now here's the trick to making this easy. Make your table by choosing your y values to calculate x's from the exponential form. Instead of always picking our x's and trying to find our y's, in this case it's going to be easier to pick y values to plug in as our powers and work back to find our x's. So in this one, we said 3 to the y equals x. So 3 to the negative 1, remember it flips it over, so we get 1/3. Anything to the 0 power is 1, and 3 to the first power is 3, and 3 to the second power is 9. So we're going to plot our points over 1/3 down 1, over 1 up 0, over 3 up 1, and over 9 up 2. So we've plotted our points. We're going to draw in the vertical asymptote. And if we have no shift, which in this case we don't, it's going to be right here at x equals 0. And then we're simply going to connect our graph and trail off with our asymptote. So we're coming up along this vertical asymptote, and we're going to go through our points here and curve off to the right. That's a very standard log graph. So in this case, our domain is all of the x's to the right of that vertical asymptote. So our domain would have to be all x's that are greater than 0. We're never going to touch that red vertical asymptote. But our range can be anything because our y values are going to keep going lower here, and as we move to the right, our y's are going to get taller just very gradually. So our range is all reals. And the asymptote we said was a vertical line. It would have the equation x equals 0. All right, let's try another one. Y equals log base 4 of x. So our first step again is going to be to do our little loop. So 4 to the y power gets us an x. We're going to pick our y values, negative 1, 0, 1, and 2, and we're going to plop them into our equation for y. So 4 to the negative 1 is 1/4. 4 to the 0 is 1. 4 to the first power is 4. And 4 to the second power would be 16. So we're going to plot the points over 1/4 down 1, 1, 0, 4, 1, and then 16, 2. And it's way off our graph, but we at least have something to kind of aim at. Again, we have a vertical asymptote, so we're coming up along that y-axis and curving off to the right. The equation for that vertical asymptote is x equals 0. Our domain is everything above to the right of 0, and our range is all reals. So we can do shifts, transformations, just like we've been doing for all of our functions. If we put a number in front of our log expression, it's going to be that stretch, compression, or reflection again. If we have something inside with x, so it will be in parentheses, you'll have an x minus h. Now we're talking about some kind of left or right shift, and then our k value here would be our up or down shift. So our whole equation looks like that. But when we do the parent function, our parent function is really just y equals log base b of x. All right, and then we'll do any kind of shifting, left, right, up, down, stretching after that. Okay, so in this example, we have y equals log base 4 of x minus 3 plus 4. Notice the parentheses there. So our parent function, again, is just this first part, okay, log base 4 of x. So we're going to rewrite this exponentially. So 4 to the y gets us an x. Now this is the same function that we graphed right here, 4 to the y equals x. So let's plot those starting points again, and then we'll shift them. So we had the point 1/4, -1, 1, 0, 4, 1, and then we had that one off our graph at 16, 2. Okay? Our translations for this one, because of this 3 here, we know that we are going right 3, and then because of our 4 on the outside, we're going up 4. Now, remember that asymptotes move along with your points. So we're going to shift all of these points, right 3 and up 4. Okay, so I started with the 4, 1. We'll skip the 16, 2 point since it's going to get even further off our graph. But the 4, 1 is going to shift right 3 and up 4 and land here. 1, 0, we go right 3 and up 1, 2, 3, 4. This 1/4, -1, we go right 3 and up 4. And our vertical asymptote that used to be here is now going to go right 3 as well. So our new vertical asymptote is going to be right here. And our graph then would be coming up along that and curving this way. All right, so our domain in this case, since we moved the asymptote to x equals 3, we went right 3, our domain is going to be everything to the right of that. So x has to be greater than 3. Our range is still going to be all real numbers. That's going to be the case for all of your log graphs. All right, let's try a couple more here. We have y equals 5 log base 2 of x. So we are going to start out with our parent function, y equals log base 2 of x. We're going to convert it into our exponential format. So start with your base and do your loops. So 2 to the y has to give us an x. So 2 to the -1 would be 1/2. 2 to the 0 is 1. 2 to the first power is 2. And 2 to the second power is 4. We then have to do a vertical stretch of 5. So we're going to multiply all of these y values by 5. And we get -5. 5 times 0 is still 0. 5 times 1. And 5 times 2. All right, so we're going to plot our points. Over 1/2, down 5. Over 1, up 0. Over 2, up 5. And over 4, up 10. So you can see that our graph, we haven't shifted left or right at all. So our vertical asymptote is still here right on the axis. But you can see that our points are coming up along there and are really stretched tall. So domain, x would be greater than 0, or to the right of that x-axis, that y-axis. Our range is still all reals. Our asymptote hasn't shifted, so it's still at x equals 0. All right, our next one here, we have y equals negative log base 5 of x plus 1. If we look at the transformations, this negative in front is going to cause a reflection over the x-axis. And this 1 here, the positive 1, is going to shift it left 1. Okay, so let's start with our parent function. Y equals log base 5 of x. We do our little loop. So 5 to the y has to give us an x. So let's graph that. Plugging in negative 1 for our power, we get 5 to the negative 1 would be 1/5. 5 to the 0 is 1. 5 to the first power is 5. And 5 squared is 25. That's going to be off our graph, but we can graph the other three. So over 1/5 down 1, 1, 0, and 5, 1. Okay. Now we said we have to reflect this over the x-axis. So our y values are actually going to flip-flop. So our negative 1's become positive 1, 0 is still 0, 1 becomes negative 1, and 2 becomes negative 2. So let's reflect these over the x-axis. We have the point over 1/5 up 1. 1, 0 is still where it was. 5 ends up being at negative 1, and then 25 would be over here at negative 2. So our graph is looking like this. Okay, now that's the reflection of it. Now we still have to shift everything left 1. So we're going to take our dots and shift them all left 1. And our asymptote is also going to shift left 1. So we have an asymptote here at x equaling negative 1. And our graph now is going to come down along this and curve off to the right. Domain now, since we've shifted everything to the left 1, our x's have to be greater than negative 1. They're to the right of that asymptote. Again, these are tied together. And our range, again, is always all reals. All right, so when does our vertical asymptote move? It moves with any left or right shift. What is the range always? We said it's always all real numbers. And what changes the domain? Again, any kind of left or right shift is going to alter the domain. These are going to go together. So any kind of movement for your vertical asymptote is going to affect that domain. All right, let me know if you have any questions about graphing logs.